Okay, this is geometry, section 7-6, parts of similar triangles. It's on page 544. And really what we have is some theorems that are kind of interesting that we don't use a lot, but they're available if you need them, okay? And we start on page 544 with the three theorems. And I'm going to put the three together, kind of, and show you what I mean by different pictures, okay? So it says, if I'm looking at theorem, special segments of similar triangles, and this is 7.8, 7.8, 7.9, and 7.10. If two triangles are similar, okay, that means their angles are congruent and their sides are in proportion. I've said that a lot because that's important. The lengths of corresponding, okay, now this is where I'm going to differ from the book. Corresponding, and I'm going to differ from the book because I'm going to put all three of them together. Ooh, can you read that?
No.
No. Okay. I was going to choose a different color and be all fan-dancy, but I'm not sure that's going to work. Here's my red. Alright, let's try this. How's that? Corresponding altitudes. Okay, this is 7, 8. I'm going to add a word. Angle bisectors. This is theorem 7, 9. You'll notice I'm putting all three into one. And medians. And that is 7, 10. So these three, all right, are proportional to the lengths of the corresponding sides. Okay. Now I'm assuming that you know what altitude, angle bisectors, and medians are. So you may have to help me out with that if you're not. But let's take a triangle. Okay, we'll call this triangle A, B, C. All right, and it is similar to this triangle. D, E, F. Okay, we got it? Now I'm going to draw the altitude of this one from angle A. Now, how many altitudes does a triangle have?
3.
It has 3 altitudes. I'm drawing one, and I'm drawing this corresponding altitude. In other words, if I say that triangle ABC is similar to triangle DEF, okay? So A matches D, B matches E, and C matches F. Does that make sense to you? Okay, so did I get that right? A, whoops, no.
Would it be E?
Yeah, I'm sorry. It would be E. I didn't. It'd be E, D, F, right? Thank you. Remember what I told you? There's my first one. Okay, that's one. All right. So I drew the altitude, correct? All right. And so what this says, I'm going to call this X and this Y. Okay? What this says is that the altitude, AX, okay, over EY. So this altitude over this altitude is equal to any of the corresponding sides. So we would say AC over what? EF. And we could also say AB over ED. And here's the weird one. We can also say BC over DF. So it works for all three. Now, if you look in the book, it doesn't have that. Okay, it does one side, but it works for all three. Okay, Chinny, do you understand that?
Yeah.
Okay, so let's do the same thing. All right, we're going to do the same thing. We're going to call this A, this B, and this C. And I'm going to do the same thing over here. I'm going to call this D, E, F. Now, I'm going with this concept right here, right? That the two are similar, right? But now I'm going to draw the median. What's the next one? Nope, angle bisector. So I'm going to draw an angle bisector here and call this X. I'm going to call it angle bisector here and call this Y. So this is equal to this, and this is equal to this. Do you well, actually, they would be equal. Why? It would be one mark. Why are they all equal? Yeah, they're similar, so the angles are congruent. Okay? All right, so these are angle bisectors. So what the next theorem says, 7, 9, is that AX, which is the angle bisector, over EY is also in the same proportion. So AC over EF equals AB over ED. It's the same as right here, guys. Equals BC. So if you can't read my writing, just write the same thing, DF. Okay? So in other words, the medians are in the same, the angle bisectors also are in proportion. Okay? All right. Any questions? Now the third one is the same thing. I'm going to draw the same triangle. Well, actually, I'm trying to draw the same triangle, but do you notice how it gets worse and worse every time I draw it? Okay. But this time I'm going to go to the median. So I'm going to go to the middle point. So that means that this is X, and this is marked congruent to that. And then this is E, D, F, and this is Y, and that's marked equal to that, right? And they are not the same length. These are not the same length, so they're different. But the same thing applies, that this median AX is equal to EY, or over EY equals AC over EF equals AB it's a B over ED equals BC over DF. Okay? So does that make sense to you? All right. So let's take a look at examples then that we could use to solve something. Okay? Let's say that we have this triangle here. This is number 1. We have this triangle here. So I'm going to draw this. Now what is that? Once I draw that, what does it become? It becomes an altitude, right? And this is P, and this is K, and this is L. This is 20. Oh, this angle, I'll draw another triangle here in a minute. And in here is 16, and this is M. So I'm going to do this and draw. And this is Y, this is X, and this is equal to K. X is equal to K, and then Z is equal to L.
Is that X in 20 or the 16?
This is an X, a capital X. This is a small X.
On the other triangle.
That's a K, M, L. 16, 20. Did you get that? Okay. All right. So we have 2 altitudes, correct?
Yes.
And we want to find the length of this altitude, and we know that the altitudes are in proportion, right? So my question is can we set up a proportion to solve for X? Does this side correspond to this side?
Yeah.
How do you know it corresponds?
Because you look at the angle.
All right, because X and K are congruent, correct? So what we have is we have X, this X, over what?
16,
16 equals
15.
15 over 20. So we go from this triangle to this triangle, back to this triangle, this triangle. Would you solve that? It would be 20x equals 15 times 16.
240.
240? Oh, well then. And so I divide by
Get 12.
20? Okay, so x equals 12. Does that make sense? All right. Okay. I'm going to give you one to do real quick to make sure that you're understanding it. Okay. This is 12, and what is that? Tell me what that is.
Median.
It's a median, all right? Okay, this is x from here to here, only from here to here, correct? All right. So now I'm going to draw another one. I'm trying to make it a little smaller. Okay, this is 8, and this is a median. That's 8. Can you read that? Okay. And this is 5 from here to here. Okay? So how do you solve for x?
X5.
X over 5?
12 over 8.
Okay, can I ask a question? The theorem says it's the whole length. How can you just take this from here to here over this from here to here?
Because they're equal.
That's right, and they're half, right? So since they're, well, hold it, I'm sorry. They're not equal. This should be a double. These lengths are not equal. But how do I still go x over 5? They're in proportion, even because these are half of the whole. So they would be in proportion also. Okay, would you solve this? 8x equals what, 60?
7.5.
60, and so we divide by 8, we get what?
7.5.
X equals 7.5. Okay. Any questions on that? Okay, so we want to talk about one more thing on page 547. This one actually has a name. This is called the triangle angle bisector. By the way, oops. The other one, the other three, you know, these three, they don't have names, but we hardly ever write them out. We just use them. Okay, so, but this one does have a name. It's called the triangle angle bisector. It's on page 547. Okay, and it says an angle bisector in a triangle. How many angle bisectors do we have in a triangle?
3.
All right, 3. It separates the opposite side into 2 segments that are proportional to the lengths, that should be plural, lengths of the other 2 sides. I'll show you what I mean here in a minute. You write that down. They have an interesting drawing. I'll try to match it. Okay? Let's say that they have this. Okay. So this is J, and this is K. This is M, and this is L, okay? I don't know if you can see the different colors very well, but what this theorem says is Well, first of all, this is an angle bisector. Do you understand that? And we have 3 of them, so this can apply to any of them. But it says, see these 2 segments that are formed on the opposite side? See this segment here and this segment here? That KM, all right, over LM. So that this piece, KM over LM, is equal to KJ. So that side from this corner to there over LJ. Okay? So this piece here over this piece here equals this leg over this leg. It's a matching leg. That's why I drew it in red. The red pieces go together and the blue pieces go together. See the red's on top and the blue's on bottom? Is that right? The red's on top and the blue's on bottom. Okay? Alright, so what it looks like is, if I gave you, I'm going to give you a little bit of a harder one than the example here, I think. We'll see if we can do this one. Okay, so this is an angle bisector. Does everybody see that? This is X. This is 14. This is 11. This whole bottom side here is 20. Okay? So what kind of proportion would I have to solve for X? What's that?
14.
This is X, the whole thing is 20. This is 14, and this is 11.
Isn't X half a 20?
No, not, you don't know that it is.
Okay.
So we put X over what? What's this piece here? Unknown. Well, we do kind of know it. Here's, what's that?
20 minus.
Do you want to explain that?
It's just how you solve it.
Yeah, if 2 numbers add up to 20, and one is X, the other one is 20 minus X, right? This equals, now what?
14 over 11.
14 over 11. So when I cross multiply, watch this guys, you're going to multiply by the quantity 20 minus X. 14 times the quantity 20 minus X. Notice I have parentheses because I got to distribute that. Equals 11X. So when I distribute, what's 14 times 20? What? 280? Minus 4, what's that?
280.
It's
280.
280, right? Equal. All right. And now I'm going to subtract a negative 14x, which is the same as adding 14x. Is that correct?
Yep.
Okay. So I'm getting 280 equals 24x. Does 280, can you divide that out? Does it work?
Oh, no.
It gets 25.
Yes. Oh, it is.
Oh, it's 25x. Thank you. Boy, that changes the whole, I mean, it's still a fraction though, isn't it?
Yeah. 11.2.
11.2? Okay. X equals 11.2. Okay, do you see how to do that? Are there any questions about that? Okay. So the first set of directions, 6 through 16, you're just finding X using those theorems. Okay?
What page is this?
I'm on page 548, and then 20 through 23 you do the same. Okay, only it's a little bit harder. So let's take a look at one of those, all right? We're going to go to 23, so let's take a look at 22, shall we?
Yes.
Okay, so 22, it looks like this. Angle bisector, correct?
Mm-hmm.
Says that this is equal to this. And we get 21, and then this little piece is 2x plus 6. This little piece from here to here is 2x plus 6. Right? All right. Well, since this is an angle bisector, we can use that theorem that we just talked about, can't we?
That one side is 16.
Is what? Oh, 16. Well, that's awesome. Because I'm sitting here going, oh, I don't know how we're gonna figure this one. But we can do this. We can go 2x plus 6 over this piece here, correct? Which is what? 16 equals 16 over 21. So, when you have these two equal to the same thing, okay, that means these two are equal to the same thing. Do you know that? Okay. Well, we'll just continue on then. What's 16 times 16?
256.
Okay, so 21 times 2x plus 6 equals 256, correct? So 21 times 2 is 42x plus 126.
Yep.
And we're going to subtract 126. And we get 42x equals 0.3130. Is that correct?
Yeah.
What did you get when you take 130 divided by 42?
A decimal.
What is it?
3.1.
3
Well,
point,
rounded.
3.1. Okay, very good. You got it? Okay, so your assignment, let's see if I can get it right, is page 548, numbers 6 through 16, comma, 20 through 23. When is it due? Monday. Okay, ladies, you just put it underneath my door. And then the other one is due tomorrow, correct? All right.